Hi, I'm Morris Pelzel, and this is my midterm project, Scenario 2, a handheld wireless medical device. I'd like to quickly show you some key resources that gave me ideas and insights into the project problem space, the needs and requirements of the users, and features that I conceptualized and prototyped. Then we'll take a tour of the dynamic prototype, where I'll also mention some results from usability tests that helped me to refine the design. I quickly discovered how vast the field of medical informatics and healthcare information technology is. Soon I realized that there are two major trends in the field that are converging toward the type of device I'm designing. First, the development of electronic health records. With EHRs, medical data is collected, stored, processed, and accessed in digital form. This makes it possible to develop a comprehensive personal medical record that can be managed among the patient and his or her various healthcare providers. This movement received a major boost from the 2009 stimulus legislation, which allocated nearly $20 billion to promote the development and adoption of EHRs among medical providers. Here's the website of the agency in charge of this program, healthit.gov. The term interoperability points to one of the main challenges of developing EHRs, coming up with standard nomenclature, categories, and coding for medical data that can be shared among the many different kinds of medical professionals and that can be structured for electronic processing, searching, and easy access. The development of Pulse presupposes advances toward a set of standards for medical data. A second major trend I learned about in healthcare information technology is the development of wireless mobile digital diagnostic and monitoring devices that can measure various physiological metrics. These devices, which make use of sensors to create what some call a body area network, are increasingly being used by both professionals and patients themselves to gather health data. Here are a couple of resources that promote this trend. The first is a TED Talk from 4 years ago describing what Dr. Eric Topol called the wireless future of medicine. Let's listen to a short clip from that talk.
Does anybody know when the stethoscope was invented? Any guesses? 1816. And what I can say is in 2016, doctors aren't going to be walking around with stethoscopes. There's a whole lot better technology coming, and that's part of the change in medicine. What has changed our society has been wireless devices. But the future are digital medical wireless devices, okay? So let me give you some examples of this to kind of make this much more concrete. This is the first one. This is an electrocardiogram. And as a cardiologist, to think that you could see in real time a patient, an individual anywhere in the world on your smartphone watching their rhythm, that's incredible, and it's with us today. But that's just the beginning. You check your email while you're sitting here. In the future, you're going to be checking all your vital signs. All your vital signs. Your heart rhythm, your blood pressure, your oxygen, your temperature, etc.
I also want to mention something called the Tricorder X Prize, which is offering a $10 million reward for the development of a wireless handheld health device that recalls the tricorder, a science fiction diagnostic device featured in Star Trek. This is another illustration of the energy and interest in mobile medical devices that capture physiological data. I now realize that the future belongs to a device that brings together the push for electronic health records with the drive toward mobile wireless diagnostics. I decided that Pulse needed to do both in order to compete in the market of the future. Among other things, the device needed to be able to work with sensors to monitor a significant number of health metrics and automatically add data to a person's electronic health record, while also allowing for access to the EHR and the input of other data into the record. At this point, I wrestled with an inherent tension in these trends that directly affected the design process. Should the primary users be medical professionals or patients and consumers themselves? On the one hand, there is a strong movement toward persons taking ownership of their own health care and monitoring their own health metrics. On the other hand, medical professionals are rightly concerned that consumers will be tempted to self-diagnose and treat in situations where the expertise of a professional is called for. I surmised that the future market will have a place for both a professional and a consumer model of the type of device I am designing. However, given the constraints of time, I decided to focus on developing the professional version, meaning my users are going to be healthcare providers and not the general public. As I continued reflecting on requirements and possible platforms for Pulse, my research led me toward designing for a device using Apple's iOS operating system. I decided to develop on the iPhone platform with the hope that in the future a somewhat larger, though still handheld version of the iPhone will emerge. One of the key sources that moved me in this direction was this article entitled, "How the iPhone is Enabling a Revolution in Connected Medical Devices." I would just quickly like to highlight several key points that I gleaned from the article. First is the survey data showing that, at least among physicians, the iPhone adoption rate is very high, in the range of 75%. This means that there is already a strong familiarity with the iOS features and navigation among a significant set of my users. Second, many medical device companies, such as Airstrip Technologies, are developing on the iPhone platform, as you can see here with Airstrip OB, which allows for remote labor and delivery monitoring. Another company, Y-Things, selected the iPhone as a deployment platform for their medical devices, noting that the iPhone sets a reference for simplicity to the user. Simplicity is the key and the most important point if a manufacturer wants a new device to be adopted by the consumer and to be used in the long term. Still, other companies explain why they are working with Apple. Noting, for example, iOS's strong penetration and growth rate, the maturity and sophistication of the app development process, and Apple's commitment to developing the app accessory space, as well as the quality of the iPhone camera and the fact that the iPhone is popular and widespread among doctors. Having made the decision to design for the iOS platform, I began to investigate the principles of iOS app development. These iOS design resources were instructive. In particular, the Human Interface Guidelines provided extensive guidance for issues such as layout, navigation, interactivity, and other design basics and strategies. In my design, I tried to embody the principles such as defer to content, provide clarity, and use depth to communicate. So with this quick look at some of the background of my design process, let's go now to the dynamic prototype of Pulse, which I built on the Proto.io website. The Pulse icon appears on the main iPhone screen and when tapped, opens up to an authentication page. My research indicated that security and privacy were critical elements of any device handling medical data, so I designed a robust authentication system. The camera icon is a facial recognition element. The user enters a passcode and looks at the camera icon. If the ID is verified, then the user is admitted to the application. Pulse has two persistent bars below the status bar. The first is a user information bar, giving the user's name and institutional affiliation as well as the current date. Second, there's the main navigation bar with 10 icons that control various aspects of usage and navigation. These should be familiar to the user. In order, there's a home icon, which takes the user back to this screen, the back and refresh icons, messages, notes, camera, voice, help, lock, and drop-down sidebar. Several of these will be demonstrated shortly. Pulse presents the user with an action sheet to begin operation. My assumption is that the user will begin in one of these three modes. Device settings is similar to the general settings area of the iPhone, and in the interest of time, I did not further develop screens for it, as most users will access it infrequently once initial setup is done. In the main, then, there are two pathways to consider at first. Medical Resources takes the user to a screen with icons to open up further applications accessing healthcare and medical resources. Pulse will come with some standard apps already included, but the user will be able to customize this area and add their own resources. The other main pathway for the user is to interact with the patient and his or her data, which is begun by tapping the Select Patient button. I assume that as a medical professional, the user will have some number of patients who form that user's clientele. Patient names are listed in alphabetical order, and there are prominent affordances for searching and for adding a new patient. I wanted to keep this page and really the overall design as a whole as simple, minimal, and uncluttered as possible. I presume that the user will be dealing with one patient at a time, and will begin by selecting that patient. In this case, I have made Felix Culpa an active patient. Tapping on the patient name brings up a screen with an overview of that patient's basic information, including administrative and contact data, as well as things like weight and height, blood type, and current medications. This screen could probably be expanded to contain further items, but this gives you a basic sense of where a user would start with a particular patient. The patient name is clearly displayed under the main nav bar, and the high contrast should help the user be very confident that they are working with the correct patient records. Notice that a new button bar has appeared under the patient's name. These buttons represent the major categories of the patient's electronic health record. This bar will remain persistent as long as the user is working within an individual patient's records. Once that patient record is exited, this bar will go away. Tapping on these buttons will bring up progressively more specific elements of the electronic health record. For example, tap on Vitals to see the most recent readings of a range of key physiological metrics. Pulse should be customizable so that, for example, a user has some ability to modify both what metrics fall under the category Vitals and how they are displayed. Switching over to Radiology, list all patient images and scans by type, description, and date. Tap on the description of the scan, and the image opens up on the screen. Tapping on the patient's name will always take the user back to the patient overview page. From the patient overview page, the user can activate the sidebar icon on the far right of the nav bar. This will open up a listing of all the metrics that Pulse itself can measure, and toggles between the sidebar being visible and hidden. To keep the workflow as simple as possible, this can only be done from the patient overview screen. Tap on heart rate, for example, will bring up Pulse's capacity to measure the patient's heart rate. Once the measurement is taken, it is automatically added to the record. Now some of the other features of the nav bar. Messages allows the user to both read and compose messages. This feature is distinct from the user's more general email. Notes allows the user to use either the iPhone keyboard or a digital pen to compose notes. When Notes is accessed while a particular patient's records are open, the Add sign will automatically add the completed note to the Notes section of that patient's records. Camera accesses the built-in iPhone camera in order to take pictures and video, which would then be added to the radiology section of the record. Voice gives the user the ability to record a spoken message and add it as a speech note to the record. It might be possible to incorporate speech-to-text software to transcribe the message either in real time or later. There's a standard help section, which I haven't built out here, and the lock icon, which the user can tap to immediately take the device back to the authentication page. This would be helpful, for example, if the user needed to put down the device while examining the patient and wanted to make sure to avoid the possibility of the device being taken by someone who might want to access other people's data. So that is a basic overview of Pulse. Feedback from usability tests and my own walkthrough resulted in a couple of key refinements. First, accessing the built-in monitoring feature was redesigned. Originally, it had been part of the button bar containing the major record sections. I made it into the sidebar feature with the icon in the main nav bar in order to more clearly differentiate the accessing of records from the monitoring of metrics. Second, the lock feature was added in order to enhance record security and privacy. My sense is that Pulse is on the right direction toward the kind of wireless handheld medical device that will become common in the future.